Let's see the solutions now. The first question is actually very simple. You can solve the block diagram quite easily, and after finding the transfer function of the resultant block diagram and comparing it with standard form of second order control system, you will get the value of natural frequency equal to 10 radian per second and the value of zeta to be equal to 0.5. Now let's come to the next question. This question is actually a very good question. For better understanding, it will be better if we divide the input signal into two parts, the constant one separately and 0.1 sine of 10t separately. We can do this here only because we are considering linear time invariant system, and particularly it is a property of linear system where the output of two different signals is exactly equal when the input is the sum of two signals. You should always keep this point in your mind that we can do this only for linear systems. And fortunately for you, in undergraduate level studies, LTI systems are considered mostly. Now we consider the sinusoidal signal. We know that for sinusoidal signals, we put the value of S equal to j omega by ignoring the damping factor sigma. The resultant magnitude of the transfer function when the angular frequency is 10 will come out equal to 100. And we also know that the magnitude of input signal multiplied by the magnitude of transfer function is exactly equal to the magnitude of output function. We will get the value of b equal to 10. If you have calculated up to this only, then also you could tell which is the correct option because there is only one option where the value of b is equal to 10. But even then, let's see how to find the value of a, which is actually the very tricky part. Many students will commit mistakes assuming the signal 1 to be a unit step signal, which is absolutely wrong. Unit step signal starts from t is equal to 0, but a constant 1 is very different from a unit step signal. Here, we will assume the input signal 1 to be a sinusoidal signal with frequency 0, which in other words is a simple DC signal. And after that, we can easily find the value of a, which will come out to be equal to 1, and hence the correct option is the third option. Now let's see the next question. This question is very simple. You can easily find the characteristic equation, and after that, forming a root array, you can easily determine that the system is stable only when the value of k is greater than 5. Now let's come to the next question. We have another very interesting question which will confuse a lot of students. Particularly the word capacitor in the question will make students think that probably a concept of capacitor is used here. However, many times these type of terminology are used just to confuse the students. Now let's see the solution. The universal definition of error signal is Rs minus Cs, and to find the steady state error due to the disturbance signal Ds, we have to put the input signal equal to 0. Here also, the linearity property is used. This is not the steady state error of the output. This is the steady state error of the output which is caused due to the disturbance signal only. And for that, we have to assume the input signal Rs to be 0. The resultant input signal will be equal to negative of Laplace transform of the output signal Cs. From the block diagram, we can easily write the equation of Cs, which will come out to be equal to error signal Es multiplied by transfer function of compensator plus disturbance signal Laplace transform, the whole being multiplied by transfer function of the plant. Putting this equation in the error signal, we will get the equation of error signal in terms of Laplace transform of the input signal and the transfer function of compensator and plant. And after putting the value of different parameters, we will get another equation of error signal which will initially look very complicated. And here only the question will determine how smart you are. Suppose this question comes in your exam and you are unnecessarily trying to simplify this. You will definitely get the answer but will waste a lot of time. We are supposed to find the steady state error which is equal to the limiting value of the function s multiplied by Laplace transform of the error signal Es when the value of s tends to 0. Since we have to finally put the value of s equal to 0, it will be much better if we cancel all the terms consisting of s, and that's how you will save a lot of time by not simplifying the equation of error signal. After removal of all the terms consisting of s, we will have a very simple equation which is minus 2.2 divided by 1 plus 2.2k. And in the question it is provided that the steady state error should not exceed 0.1. So after equating this equation with 0.1 and solving further, we will get the minimum value of k to be approximately equal to minus 10.45. Now let's see the next question. This is another very simple question which may confuse few students just because of the word capacitor which is present in the question. However, this question does not use any property of the capacitors at all. Actually, there is a unit named capacitor and controller. There, you will study few more concepts regarding capacitors and controllers, but there are a lot of questions which try to confuse the students with these terminologies. However, they do not use any concepts related to them at all. In this question, you can easily find the closed loop transfer function, and after comparing it with the standard form of second order transfer function, we will get the value of natural frequency to be equal to 12 and zeta equal to 5 divided by 12. We also know the formula for damped natural frequency is natural frequency omega n multiplied by under root of 1 minus zeta square. After putting the value of different parameters in this equation, you will get the value of damped natural frequency to be approximately equal to 10.90. Now let's see the next question. We are provided with a transfer function which is having a DC gain of 5. For DC gain, we know the value of s equal to 0. We just saw a question previously where we were having an input signal which is a constant signal 1. There also we have put the value of s equal to 0, and here also it is 0. Coming back to the question, since we have the DC gain, we can easily find the value of p by putting the value of s equal to 0 in the transfer function. After that, we will get p is equal to minus 20. For frequency response, s is equal to j omega, and the magnitude of this transfer function will come out to be equal to minus omega square plus 100 divided by under root of omega square plus 400. For unity gain, this magnitude has to be equal to 1. We will get another equation after solving which we will get the value of natural frequency omega n to be equal to 8.84 radian per second. We will actually get two values, one positive and one negative, but obviously negative values does not make any sense. Now let's see the seventh question. Another simple question in which you have to first find the characteristic equation. After that, we have to form the root array, and in the third row we will get an element in the form of variable parameter k. But to have poles on the imaginary axis, this element needs to be 0, and for that the value of k should be equal to 8. Now let's see the last question, which is also a very simple question. The only time a student will take in solving this question is actually in solving the block diagram, but that also is the most basic skill a student should have to have good command in the subject control systems. After solving the block diagram, you will get the transfer function, the denominator of which is simply the characteristic equation, which will come out to be equal to s raised to the power 4 plus 21s cube plus 20s square plus 20. Clearly this is a first order equation, and the system is unstable because there is one term which is s raised to the power 1 which is missing in the characteristic equation. We have seen in the lecture of Routh-Hurwitz's criteria that if the characteristic equation misses any term, then the system is simply unstable. However, interestingly, if two terms are not present, like for example, suppose the term consisting of s cube is also not present, then there is another possibility that the system is marginally stable. Well, this point has to do nothing here. I am just telling you for your knowledge. If a single term is not present, definitely unstable. But if even number of terms are not present, then there is a possibility of the system being marginally stable. However, one thing we can say for all cases that the system is definitely not stable. It may be unstable or marginally stable, but definitely not stable. I hope you are getting what I am trying to say. It will be much better if you practice at home and take these questions as a small test, as here you are having a pressure of term foundation, and trust me, you will be having much more pressure in the final exams. So it will be much better if you first practice enough to get full confidence, then only try to attempt the questions in the next videos.